Metal printing has been around for 10 plus years, and it's been used increasingly to make molds for injection molding.
It allows you to build what you want, right? Where with traditional manufacturing, we've got bricks that we machine away. With metal additive, you're actually just printing what you need.
But the challenge has been that the surface finish and the resolution of the existing technologies just isn't delivering what the industry needs.
And I think a lot of the challenges we're going to have is on the design side. People are used to designing for traditional methods of manufacturing and not necessarily additive.
Every other metal printing technology in the market today that's used for tooling delivers a surface finish that's about 80 grit sandpaper, and it's wavy. As a result of that, there's a significant amount of post-processing that's needed on those parts before they're ready to go into an injection mold machine.
3D printing of metal parts for tooling itself, it allows you the ability to be able to do conformal cooling. And I think that there's an advanced opportunity if you start to do lightweighting of materials.
They've been very successful, however, at enabling new geometries that can make the tool more efficient. That's called conformal cooling, which if you have a very deep core, you can conform the cooling lines to that shape. It's one of those rare instances in engineering where you can sort of have your cake and eat it too. You can both get better quality parts and more parts per hour. But when using metal printing to achieve that, with that rough surface finish, every surface of the mold component will need to be reworked, post-processed, either with a CNC machine or with electric discharge machining, which is really time consuming. So that's been a barrier because it means that your tool ends up taking about 20 to 30% more time to get done and costs 25 to 30% more as well.
From the conformal cooling side, without doing a cooling analysis, is where the limitations are, right? You can actually do more damage by designing in conformal cooling and cause worse cycle time because you got too much cooling in there and you have to play around with your process to dial it in better. Where if you use the software that's available now, like Moldex 3D or whatever the softwares are, to be able to perform the cooling analysis to make sure you've got the best, most adequately designed waterline, that's where the best bang for the buck is going to be on the overall process.
The use of conformal cooling lines is something that a lot of people get worried about. They're like, oh, if I'm going to do 3D printed tool, I'm going to have to get software that helps me optimize those cooling lines. But to be honest, it's very self-evident how to design a cooling line that conforms to the shape of the mold, right? If I have a mold that looks like this, I should put a cooling line that follows equidistant from that and go back and forth. So the 80% of the productivity gain that comes from conformal cooling, anybody can do.
Yeah, you're optimizing the process for what you really need at the end of the day. And it may be a cycle time saver, it may not. It may be just that you're getting better part quality and not necessarily a cycle time saving. And I think that's where the education, the industry really needs to happen. Too many people look at it that it's like a one-stop solution to the next best thing. And it's really just another tool in your toolbox, right? If you look at like I mentioned before, like if you look at like EDM didn't replace CNC, right? It was another tool in your toolbox to get something done. And additive is the same thing. It's not a solution for everything. But learning to do it the right way is key to the industry.